So Perla, this video I'm making you, I'm not going to try to get through the whole handout that you sent me. I will help you with all of it, I promise. But I thought it might be a bit much to do in one video. Plus YouTube limits me to 15 minutes. So what I decided to do was start with problem number 2, because it's really just dealing with the values of sine, cosine, and so forth at either pi over 3 or pi over 6 or multiples of pi over 3 or pi over 6. So what I did, if you look below the unit circle there that you were given, I reminded you of what each of those values is equal to. So the cosine at any angle is just the x value, the sine is the y value, and the tangent is y over x. And then secant is the inverse of cosine, so it's 1 over x. But we literally, if it's a fraction, we're just going to flip the fraction over. Cosecant is the inverse of sine, and cotan is the inverse of tangent. So I'm guessing that generally, because you said you feel pretty overwhelmed right now, I'm guessing that the way this circle is structured and where these values come from are still a little confusing to you. I would like to explain that to you in person, not in a video. So for right now, we're just going to work off of the values that were given in the table and see if we can answer these 8 questions. So A asks what the sine at pi over 3 is. So if I go to pi over 3, which is the same as 60 degrees, I'm going to highlight it in yellow. Well, actually, maybe I'll do red. So right here, that's pi over 3, and you can see they've marked it for you also. That's the same as 60 degrees. And angles are always measured with respect to the horizontal. So starting at 0 and going counterclockwise, if I move 60 degrees, that's the same as pi over 3. And there's a way you can do that conversion. I'll show you that when I see you at school. But basically, if they're asking for the sine there, they're just asking for the y value of the coordinates at that point. And we can see that they've given us that. The y value there is just the square root of 3 over 2. And you are done, except I wrote it wrong. Square root of 3 over 2, okay? B asks about the cosine at 2 pi over 3. So if this is 1 pi over 3 is 60 degrees, then if I double that, I'll get 2 pi over 3, which means I just have to travel another 60 degrees. And so we can see that right here, this angle right here, that's going to be 2 pi over 3. So, and if we look for the cosine, that's the x value there, that's going to be negative 1/2. Now the next one, C, is going to be a tangent value. Tangent is y over x. We're at 0, so if we look at 0, we can see that the y value there is 0, and the x value there is 1. So 0 divided by 1 is just 0. Now D asks about the cosecant at 4 pi over 3. So this was, right here was 1 pi over 3. This was 2 pi over 3. If I go another 60 degrees right here, this is 3 pi over 3, which reduces to pi. So if I go another 60 degrees, I'm going to be at 4 pi over 3. So that's right there where I put that red X. And we're looking for the cosecant. Well, the cosecant is 1 over y, but I can also just think of it as the inverse of the sine there. And sine is the y value. So the y value there is negative radical 3 over 2. What I'm going to do is I'm just going to invert that and say it's still negative, but the 2 will now be on the top and the square root of 3 will be on the bottom. So again, I took the y value at 4 pi over 3, and I just inverted it, flipped it over to get the cosecant there. Now you do have an issue. You're not allowed to leave that radical 3 in the bottom of the fraction. So we're just going to rationalize the denominator by multiplying by whatever the denominator is. So in this case, radical 3 times radical 3 is just 3. Those square root signs cancel each other out. And on the top, I'm going to have a negative 2 radical 3. So your final answer there is just negative 2 radical 3 over 3. All right, so that now we're moving on to a multiple of pi over 6, and specifically just 1 pi over 6. So if it's all right with you, I'm going to clean up some of my markings here. And let's look at pi over 6. So that's literally 30 degrees, and you can see that they've marked it for you. So right here, that's 30 degrees, or pi over 6. And the sine value there is the y value, and we can see that that's 1/2. So I'm just going to put a 1/2 there. Now, the cosine at 5 pi over 6 is the next one they ask about. So we can count. If you're not, you say, how do I know where 5 pi over 6 is? Well, every 30 degrees is going to be a pi over 6. So 1 pi over 6 is 30 degrees. If I go another 30 degrees, that's 2 pi over 6, which does reduce to pi over 3. The next 30 degrees would be 3 pi over 6, but that reduces to pi over 2. And then it's 4 pi over 6, but that would reduce to 2 pi over 3. And then the next one is 5 pi over 6, so it's right here. So it was 1, 2, 3, 4, 5. That's how I found 5 pi over 6. And 5 pi over 6, the cosine there is the x value, and that looks like negative radical 3 over 2. So we're done with that one. Now the next one they ask you about is the secant at 2 pi over 3. So again, I'm going to clean up my markings here. So 2 pi over 3, again, we're just going to count. So 1 pi over 3 is right there. So 2 pi over 3, I just have to go another 60 degrees, is going to be right where that second blue X is. And they're asking for the secant. Well, secant is the inverse of the cosine. And we see that the cosine is the x value, which is negative 1/2. Now we'll still have the negative sign, but we're going to invert that, and it's going to be 2 over 1. But I can just write that as negative 2. I can drop the 1 on the bottom, okay? So that's G. And then H wants the cotan at pi over 3. So now we're back at this first blue X. That's pi over 3. Cotan, I have to take the X value and put it over the Y value. So the X value there is 1/2. So I'm going to have 1/2. And I'm going to divide that by the Y value, which is radical 3 over 2. Now, what you can do there is you can actually cancel those 2's, but I'm going to show you how that works out algebraically. This is really, I have the 1/2, and rather than dividing by this fraction right here, I'm going to multiply by its reciprocal. So that's going to put the 2 on the top and the radical 3 on the bottom. And now the 2's top and bottom cancel. So what I have left is just 1 over the square root of 3. But again, I can't leave that radical 3 in the denominator. So I'm going to multiply by the square root of 3 top and bottom. And on the top, I'm just going to get the square root of 3. And on the bottom, the square root signs will cancel, and I'll just get a 3. So my final answer for this last one is radical 3 over 3. Let's take a look at the next set of questions. So Perla, this next set of questions, what they're getting at here, notice they gave you the values for cosine at pi over 3 and sine at pi over 3, and then they want you to work through some of the other values. Well, one of the things that they are trying to get across is the idea that cosine is what we call an even function and sine is what we call an odd function. And basically what that means is cosine, when you put opposites in, you get the same thing out. So like cosine at pi over 3 is 1/2. Cosine at negative pi over 3 should also be 1/2. But let's just check that on the circle. You can see I've copied a picture in. So Positive pi over 3 obviously is right here. And we can see that the cosine, the x value there is 1/2. If we go negative pi over 3, that just means we go in the opposite direction. We go clockwise instead of counterclockwise, 60 degrees. And there it is. And so if we look at the x value there, we see that it's also 1/2. And that's because cosine is what we call an even function. In other words, whether you put positive pi over 3 in or negative pi over 3 in opposites, you still get the same thing out, okay? Let me clean that off a little bit, and let's look at the next one. So if we look at B, now sine is what we call an odd function. So when we put opposites in, we should get opposites out. And so they tell you that the sine of pi over 3 is radical 3 over 2. And remember, sine is the y value. So if we go to pi over 3 again, we can see that we do have a y value there of positive radical 3 over 2, the y value there. If we go to negative pi over 3, so again, we're going 60 degrees clockwise, and we see that the y value there is negative radical 3 over 2. So because it's an odd function, when you put opposites in, you get opposites out. Cosine is an even function. When you put opposites in, you get the same thing out. All right. Tangent, I think we can just look at that and say, okay, let's go to tan of pi over 3. Remember, tangent is y over x. So if we go to pi over 3, we see that the y value there is radical 3 over 2, and the x value is 1/2. And to save a little bit of time, I did it for you earlier in the video, what's going to happen here, and you can do the inverse and multiply, but those 2's are just going to cancel. So you're going to end up with literally just square root of 3 over 1, but that means I can just leave it as the square root of 3, okay? And those 2's, because it's the same number and they're both on the bottom of the fractions, I can just cancel those out. Now D, we're looking at secant. Remember, secant is going to be the inverse of cosine, which is our x value. So when I go to pi over 3, and again, here's pi over 3, if I go to that value, I'll make a nicer x there, I'm going to look at the x value, which is 1/2, but I want the inverse of that because I want the secant, and the inverse of 1/2 is just 2. And then cosecant of pi over 3, now that's going to be the inverse of the sine, or the y value there. So my y value is radical 3 over 2. If I take the inverse there, I'm going to get 2 over radical 3. And I think you recall we can't leave it like that. We have to rationalize the denominator. So we're going to get 2 radical 3 over 3. And then for cotan of pi over 3, cotan is going to be x over y because it's the inverse of tan, which was y over x. So if I take the x value, remember that's your cosine, so that's going to be 1/2, and put that over the y value, which is radical 3 over 2. And then remember, again, I can cancel those 2's. They're the same, and they're on the bottom of the fraction. So I'm going to get 1 over, let me fix that, 1 over the square root of 3. But I'm not allowed to leave that radical 3 in the denominator. So again, I'm going to rationalize. So I'm going to get radical 3 on the top and just a 3 on the bottom. And that's going to be my final answer there. So, Perla, I know I didn't get through a whole lot of the handout, but I think this is enough for now. I'm going to make you another video tomorrow. I won't be in the building tomorrow, but I promise I'll make you another video with more of these problems worked out. And on Thursday, we have e-learning, I believe, and we could do a Google Meet if you want, okay? But I will make you more videos tomorrow. Have a good evening.